Welcome to the deep dive. Today, we're looking at something that feels, well, pretty fundamental, a potential new phase in how decentralized systems are built. Intent-centric architectures.
Yeah, it's a big shift in thinking. For a long time, everything was built around the blockchain. The execution, the settlement.
Exactly. And this new idea flips that. It puts the user's goal, their intent, right at the center.
That's the mission for today, really, to unpack what an intent actually is in this context and why current dApps are often limited by being, let's call them, blockchain-centric.
And we'll definitely be digging into Anoma as a key example here. Plus, we have to touch on the pretty wild market debut of its token.
Sure, the theory meets reality moment.
All right, so our sources today are quite technical. We've got research papers laying out this vision, Anoma's own roadmap, and then, the hard market data on the XAN token.
It's a good mix, high-level theory and, ground-level market forces.
Okay, let's unpack this then. What exactly is an intent? Why is basing a whole architecture around it considered such a big deal?
At its core, it's actually super simple. The papers define it as just an expression of an individual's desired end state.
A desired end state. Okay, so I want this NFT, or I want to have swapped my ETH for USDC at this price, or better.
Exactly. Or even simpler, I want coffee. I want pizza. The idea of an intent isn't new technology. It's, ancient.
Right. The sources mentioned barter systems back in Mesopotamia, 6000 BC. People always had intense desired outcomes.
Precisely. What's evolved are the mechanisms to get those intents completed. Barter, then fiat, TradFi systems, then Bitcoin, Ethereum.
So the mechanism changes, but the underlying want is constant.
Yeah, and intents aren't always simple like swap token A for token B. They can have really arbitrary complexity. Think about something like a quadratic funding vote on Gitcoin. That involves multiple parties, complex conditions. It's a much more involved intent than just a payment.
Okay, so that's a key point. Simple or complex, the common element across all these applications is the user's intent.
That's what the researchers argue, yes. The primitive they all share is intent. But the problem has been that our decentralized ways to complete those intents had always been tied to specific applications.
Oh, okay. So if you build a decentralized exchange, your mechanism only understands exchange intents.
Exactly. It's application specific. The big idea behind ICA, intent-centric architecture, is to build a generalized mechanism, one that could theoretically handle any intent.
Which leads us right into the problem with the current dominant model, the blockchain-centric architectures, or BCAs, like Ethereum, right? Gen 2.
Right. With BCAs, everything orbits the blockchain. The core property they offer is programmable settlement, the ability to execute code and finalize state changes on the chain.
And that works okay for some things.
Yeah, for simpler dApps, it's sufficient. Creating a new token, an ERC20, or, basic AMM like early Uniswap versions. Programmable settlement handles that fine.
But where does it break down? What's the ceiling you mentioned?
The ceiling appears when you get more complex. Think about sophisticated order book DXs or NFT marketplaces with complex bidding, or that Gitcoin example again.
Okay, what happens then?
Well, this is where the sources talk about Gen 2.5 architectures. It's kind of a patch, really. Builders are basically forced to use traditional Web 2 components like actual centralized servers for critical parts.
Which parts?
Things like matching users' intents, discovering counterparties, figuring out the optimal way to bundle transactions, the solving part. They do all that off-chain, centrally.
And then just push the final result to the blockchain for settlement.
Exactly. So you get this hybrid system where the really complex coordination happens off-chain, often centralized, undermining the whole point of decentralization.
That makes sense. It's a compromise driven by the limitations of the underlying BCA. And I guess the other option people try is just launching their own chain, a sovereign chain.
Yeah, that's the other route. You get full control, design freedom.
Yeah.
But it's like throwing the baby out of the bathwater, as you said earlier. Well, you instantly lose composability. Your app is now isolated. You lose the network effects of being on a larger platform like Ethereum. Plus, now you're responsible for the entire security model of that chain just for your one application's intents. It's often not practical or efficient.
Okay, so the Gen 2 limitations force either centralization via Web 2 parts or isolation via sovereign chains for complex apps.
That's the dilemma these new ICA proposals are trying to solve.
Right, so ICA flips it. The intent isn't just part of the process, it is the process. The main job of the architecture is to take that user's intent, constraints and all, and make it happen.
Precisely. It's designed as a fully generalized intent completion mechanism, end-to-end decentralized. That's the key promise. No need for those Web 2 servers in the middle.
And to do that, it needs certain components, right? The papers mentioned 4 key properties.
Yeah, 4 necessary pillars. First, generalized intents. The system has to understand any kind of intent, not just specific pre-programmed ones.
Okay, makes sense. Arbitrary complexity. What's next?
Second, counterparty discovery. A decentralized way for users to broadcast their intents, like gossiping them across a network so potential solvers can see them.
Solvers. Who are they?
Solvers are the third piece, solving. These are decentralized actors, nodes on the network whose job is to find intents out there, combine them in clever ways, maybe matching multiple buy-sell orders or bundling different types of actions and compute a valid transaction or a set of transactions that satisfies those intents.
So they're like decentralized matchmakers and optimizers.
I know, yeah. They figure out the how. And the fourth piece is settlement. Once a solver finds a valid solution, it needs to be verified and finalized, usually on some blockchain.
So the user just states their goal, their desired end state. I want X to be true.
Exactly. It's a declarative approach. You declare the what, and the ICA, through its decentralized discovery and solving mechanisms, handles the how. The burden shifts away from the user needing to figure out all the intermediate steps.
Which brings us to Anoma. It seems like the most prominent project actually trying to build this ICA vision.
It definitely is. One of its co-founders described it almost like a Web3 operating system for coordination, privacy, settlement across multiple chains. The analogy used was Anoma as Windows 95.
Windows 90, okay, abstracting the underlying hardware, right? So Anoma aims to abstract the underlying blockchain.
That's the core idea. An application using Anoma shouldn't necessarily need to care which specific blockchain its final transaction settles on, whether it's Ethereum, Cosmos, or something else. Anoma handles the intent part.
And because intents are generalized, these solvers can get pretty creative, combining different types of intents.
Potentially, yes. A solver could see a fungible token swap intent, an NFT purchase intent, maybe even something involving a privacy feature like a shielded transfer, and figure out an optimal way to bundle them into one atomic transaction or batch.
That sounds powerful but also complex. How flexible is this in practice? How would a developer actually use Anoma?
Well, that's another interesting part. It's designed to be flexible in deployment. It can be its own sovereign L1 chain.
Okay, the traditional route.
Right. But it can also act as what they call an L1.5.
L1.5. What does that mean?
It means Anoma handles the hard parts, the generalized intents, the discovery, the complex solving, but then it settles the final result onto another existing sovereign chain, maybe a mature Cosmos chain, for example.
Ah, so you get the benefits of the ICA design for your complex dApp, but you don't have to bootstrap security for a whole new L1. You leverage an existing one for settlement.
Exactly. It directly addresses that Gen 2.5 problem we talk about, needing centralized components or going fully sovereign.
And there's a third option too, like an L2.
Yeah, it can operate as an L2 or roll-up. It computes the full state transition off-chain using the ICA logic, and then posts a proof, like a ZK proof, to a base layer like Ethereum to inherit its security.
Okay, that's a lot of flexibility. Sovereign L1, L1.5 settling elsewhere, L2 roll-up. It sounds technically very demanding to build something that can do all that.
Oh, absolutely. It relies heavily on advanced cryptography. The Anoma papers and roadmap talk a lot about things like distributed key generation, DKG, and ZXE, zero-knowledge execution environments, plus recursive ZK proofs.
Okay, let's pause there. For those of us not deep in cryptography, why are things like DKG and ZXE needed for this? What do they enable?
Good question. So think about DKG, distributed key generation. It's a way for a group, like the solvers, to create a shared secret key without any single solver ever knowing the whole key.
Okay. Why is that important?
For privacy, primarily. If solvers are handling user intents, you don't want one solver or even a small group to be able to see everything. DKG helps enable things like threshold encryption, keeping intent details private during the matching and solving process.
Got it. So DKG helps protect privacy among the solvers. What about ZEXE?
ZEXE is about proving computation integrity without revealing the data. It allows a solver to prove that they correctly executed the complex logic to match intents and create a valid solution without having to show all the private details of those intents or their specific computations to the final settlement layer. It ensures the solving was done right, trustlessly.
Makes sense. So these aren't just fancy add-ons. They're pretty fundamental to making the decentralized, private, and verifiable solving actually work.
Exactly. There are core components to achieve that end-to-end decentralized promise for complex operations. The complexity is kind of the price you pay for removing those centralized Web 2 bottlenecks.
It's a fascinating technical vision, really ambitious, but then there's the market. Let's switch gears to the launch of Anoma's native token, XAN. The theory sounds great, but the initial market reaction was rough.
Yeah, the contrast is pretty stark. The token generation event, the TGE, happened alongside the main comment rollout, and well, the price action wasn't pretty. XAN crashed almost 60% within the first 24 hours after hitting its initial high around $2.24.
Ouch. A 60% drop smells like a huge amount of selling pressure right out of the gate. Did the sources point to why? What was the setup?
It seems directly linked to the initial token distribution, specifically the airdrop. Anoma allocated 10% of the total supply, that's 1 billion XAN tokens, to community airdrops.
Okay, 1 billion tokens, and the key detail.
They were fully unlocked at TGE. No vesting, no lockups for that initial 10%.
Yeah.
So you instantly had a massive amount of supply land in people's wallets, essentially at zero cost to them.
Which naturally leads to
Predictable, heavy selling pressure, people taking immediate profits. It just flooded the market.
and the trading volume reflected that.
Yep, daily trading volume spiked about 40% during that crash. Now, things seem to have settled a bit. The circulating supply is around 2.5 billion XAN. The price found support around 0.11 cents, crucially holding above 10 cents for now.
Which puts the market cap somewhere in the ballpark of $250 million, give or take.
Right, so a very real, very immediate market reaction driven by tokenomics, kind of separate from the long-term architectural vision.
Okay, let's try and bring this all together then. What's the big picture takeaway for you, the listener, from all this?
I think the main thing is that intent-centric architectures really do feel like a potential third generation of decentralized infrastructure. Gen 1 was Bitcoin. Gen 2 Ethereum brought programmability, but hit limits with complexity. ICAs aim to overcome those limits.
Allowing for truly complex dApps to be built fully decentralized without those Web 2 crutches or the isolation of sovereign chains.
Exactly. It shifts the focus fundamentally, away from the mechanics of how a block gets validated towards simply enabling what the user wants to achieve their intent. The system figures out the how for you.
So what does this all mean for you if you're building in this space or even just watching it evolve?
Well, on one hand, the theoretical promise is huge. ICAs could unlock totally new types of applications, things we haven't even imagined yet, because they remove existing design constraints around complexity and coordination.
But on the other hand,
That immediate 60% crash of the XAN token is a powerful reminder. Anoma is this incredibly sophisticated system designed for logical, verifiable completion of complex user intents using cutting-edge crypto. Yet the simple, very human intent to lock in profits as soon as possible proved to be an overwhelming force right at launch. It shows that market dynamics and human behavior operate on a different layer, often independent of the elegance of the underlying technical design. That's maybe the final thought to leave you with.